right, so this is Chapter 8, Problem 9, CFIN6. We're given this table, and we're asked to calculate the expected return, and standard deviation for each of the investments. So the expected return here for ABC. Sorry, there we go. Is 0.1 times the 22% plus 0.6 times 12% plus 0.3 times 2%. We multiply those and add them up and get an expected return of 10%. So expected return for RST. That's our RST. So that's 0.1 times -2 plus 0.6 times 12% plus 0.3 times 30%. Multiply those and add them up and you get an expected return of 16%. One thing to note about these two investments, note that the return on one is high when the other one's low, and then vice versa. So what that means is they're negatively correlated. And negatively correlated assets are great for diversification, and we're going to see why here in just a second. So we'll calculate the variance for ABC, sigma squared ABC. So that's 0.1 times the 22% minus the expected return of 10. We square that, plus 0.6 multiplied by the 12% return, minus 10, square it, plus 0.3 times 2 minus the 10%, square that. That is multiply all that out and you should get 36.0. The standard deviation for ABC is square root of 36, or 6%. Okay, so the variance for RST, so we've got 0.1 multiplied by the -2 return in the first state there, minus the expected return of 16%. We square that, plus 0.6 multiplied by the 12% minus the expected return of 10%, plus 0.3 times 30 minus the expected return of 10% squared, and that is 100.8. We take the square root of that to get the standard deviation. So RST, and that's 10.04. So that's our two portfolios. The next step in so that's individually. Okay, so this is part A. This is part B. Now C asks us to form a portfolio that consists of 60% ABC, investment ABC, and 40% RST. And then now then we compare the standard deviations of the combined portfolio to that of the the individual. Okay, so what we do is we're going to take so we're going to take, we'll try to do it up here. So we'll just say outcome 1. So this so writing kind of making a mess here, but so 60% in ABC, so 0.6 times 20, 22 plus 0.4 times -2, so that's 12.4. Then the expected return in outcome 2, 0.6 times 12 plus 0.4 times 12. I can do that math in my head. That's 12. It's both outcomes are 12. Expected return in the third likely outcome, 0.6 times the 2%. We're using this one and this one here. So plus 0.4 times 30. So return in that situation is 13.2%. So instead of, if you look at these outcomes, they're very close to each other. There's very little change. So what we've done is through diversification, because these two assets are negatively correlated, we've reduced the volatility of our portfolio. So we'll see that when we calculate the expected return and standard deviation. Do that on the next page. Okay, so expected return for our portfolio is the 0.1 multiplied by the 12.4% plus 0.6 times 12% plus 0.3 times the 13.2%. So this was our expected return 1. This is expected return 2. And this is expected return 3. So multiply those out and add them up, and we get an expected return of 12.4%. Now we calculate our variance, sigma squared p. So that's 0.1 times the 12.4 minus 12.4 squared. So that term's going to cancel out. So 0.6 times 12 minus the 12.4 squared plus 0.3 multiplied by the 13.2 minus 12.4 squared, and multiply those out, add them up, get 0.29, and then you take the square root of that, and the standard deviation is 0.54%. So by combining these two assets, we've considerably reduced the risk of of this investment. If we go back, look, so the sorry for my stray mark there. Our standard deviation for ABC was 6%, and for RST was 10.4%. Our combined with the two was 0.54%, I believe. Is that right? Yes. So, and that is a demonstration of the benefits of diversification. So that is the answer to part D. If you're comparing them, because these two assets are negatively correlated, You've reduced the risk of the investment considerably, as we've seen.